All right, guys, so infinite, you know it as an asymptote. You can call it either of those things. You just need to be aware of both names. So algebraically, if I gave you f of x equals 1 over x minus 2, what can x not equal? And if you graphed it, what would happen at 2? Yes, so you would tell me, if I'm asking you about the discontinuity, you would say that is infinite at x equals 2. Infinite discontinuity at x equals 2, okay? Yeah.
Is the at symbol the same?
Is what?
Yeah, it's
The at symbol means at. Infinite at x equals 2. To tell me the location, so it's at?
yeah.
Okay. Just at. See, guys, Friday afternoons are good. All right. Sometimes I will give it to you algebraically. Sometimes I will just ask you from a graph. So if you saw that graph, I'll give you a second to jot it down. So that's completely separate. I'm saying sometimes I'll give it to you algebraically, like I'll say, here's the function, tell me where it's discontinuous. Sometimes I'll just give you a graph and say, name any discontinuities that you see.
Is that only certain ones have discontinuity, right?
Yeah, there's 3 different types, so that is one that has it.
Would the square root negative be one? All negative?
No, that's different. That's just domain. I'll go through the other 3. Yeah, I haven't shown you yet. One at a time. All right, guys, so this one, what would you tell me about the discontinuity? Infinite at, yes, infinite at x equals 4.
So you wouldn't have to do the 1 over x plus 4?
You do not need to write the equation for it. Nope, you just need to tell me where is the discontinuity. So if I give you a graph, it's really easy. You just look at it and you're like, oh, it's there, and that's the end.
Okay.
Okay. The algebraic ones, sometimes you have to do a little more work. All right, so we're okay with asymptotes. Those aren't really new to us, so okay. You're okay. The next type is called removable or a hole, which hopefully makes sense. If you remove it, then you've created a hole in your graph. All right, guys, so try this one. Algebraically, that's something I might give you. Okay, so you see right away, like -3 in the denominator is a problem, but it's not an asymptote. Okay, it's not infinite, because what could you do to the numerator? Factor it, yeah, and it would become x plus 3 times x minus 3 over x plus 3, right? You get rid of the x plus 3's. Guys, does that make sense why it's called removable? You've like removed that factor, okay? And then for where it is, it's that factor you crossed out. What would make that 0?
-3.
-3, yeah. Think back to the beginning. Remember how you looked at it and you're like, oh, x can't be -3. So you know that you have removable, or you can just call it a hole, that's okay, at x equals -3. Everybody understand why it's -3 and not +3? Yes? Ben, you have a question?
So most of the time we'll just put the denominator.
The denominator is, for the first two types, that's where your discontinuities come from. Because what a discontinuity is in a graph, it means you have to like pick up your pencil and keep going. So you either have to like move over an asymptote or go over a hole. So yes, Ben.
So x, the whole is x cannot equal negative 3 because of the behavior of x.
Okay, it's not x cannot equal negative 3. If we were doing domain, yeah, x cannot be negative 3. The location is at x equals negative 3. It's because of the one you canceled out, it's what would make that 0.
Oh,
Okay? So it's always the one you cross out. Just look at that. What would make it 0? Okay. Now, graphically, you might see something like this. So for discontinuities, I'm not going to ask you to write the equation. The only thing you're going to have to write equations for in this unit are like those piecewise graphs like we've been doing, but not for discontinuity. Discontinuity is just going to be name it and where it's in. Okay. So guys, what would you tell me for this one? There you go. Hole at x equals 1. Easy? So far, so good? Okay. All right, one more type of discontinuity. It's called a jump. Exciting stuff, guys. Jump. I guess it doesn't take you very long to write the word jump, does it? All right, let me erase a little bit of this. Go ahead and write down this piecewise equation. We'll talk about it. Not 100% of the time, but the majority of the time that you would see a jump will be from a piecewise equation. Is our jump entertaining today? All right, guys. So to figure out if we have a jump or not, you do not need to graph the piecewise function. Okay, you don't have to draw it. All you have to do is figure out the two pieces. Are they going to connect, or is there going to be a gap in between their y values? So I know where I'm looking is when x equals -1. You guys okay with that? Like, because we see this. So all I have to do is plug a -1 into each equation. So 2 times -1 plus 1. What do I get? -1. -1 minus 4. What do I get? Okay. So guys, do those match? No. What that's telling you is you have 2 different y values. So you have a jump in your graph, okay? So your answer would just be jump at x equals -1. Are we okay with why it's at x equals -1 and why that's the one we're plugging in? Like, does that all make sense to you? What? Okay. -5 is actually your y value. Right? Your y value came out as -1 or -5. So what's really happening? So at -1 for the first one, I get -1 greater than that. I know it here. So that's what one piece looks like, right?
Oh, it is less than
And then that's the other piece. Okay. Does that help you see it?
Oh, that's our.
That's technically the graph of this. I'm saying you don't need to graph it. All we care about is that these are two different y values. So if you look at the graph here, I know one of them's -1 and one of them's -5. That is not the same thing. So that's a jump at x equals. You see it? Okay. So it's not a jump at -5 because -5 would be on the x-axis, and that's not what I'm talking about. You see it? So it's not -5 because that's like, I understand it's tricky because this matches, but it has nothing to do with these other than they're different. The location is what x value are we talking about?
If that was what I was
Okay. Yes.
So we just like have to plug in like to like find out.
Yeah, just to see do they match or not. You don't have to go through all of this to go, oh, okay, that's a jump. You know, you just, if they're different, then you have a jump.
What's the difference between the jump and the
Infinite is an asymptote.
so couldn't like an asymptote sometimes love like a jump?
No, because
There
asymptotes
can't be
look
a
like
single point on an asymptote.
that.
Okay, so a jump's always going to be on the same line.
Yeah, a jump is the same x value, like, and you usually have one filled in dot and one open dot. Yeah, I'll show you graphically another jump. So let's try this one second. What would you tell me about that? And what kind of discontinuity?
Jumps.
Yes. So guys, I'll give you a second, jot it down if you need it for the example.
I was saying for the whole, are we gonna have to like plug? So you know how you have a solve for the whole and it was x equals -3.
Mm-hmm.
Do we have to plug it back in to find the y value?
Nope, because all of this is just
Yes,
where it
yes.
occurs is the x value. Yeah.
Oh, that's nice.
I know, so yeah, it's really pretty, kind of simple.
Okay.
All right, so did we understand visually what all three look like?
Yes, ma'am.
Okay. Very good, Nina. Great. Great. So that one is a jump at x equals 2.
God.
Questions so far, guys?
Will the jumps always be on the same x-axis? Or x-axis?
Yeah, the x value. Right, yeah. Because that's the whole point, is then that's where it happens. Yeah. All right, anybody need more? Let me erase everything and then I'll put it back.
What was the first kind of discount?
Infinite,
Infinite.
which we called asymptote.
So it's infinite, whole, and jump.
Yep. Whole you might see written as removable. Alright guys. All right, here we go. A couple of examples. What? You sure? Okay. All right, so now you know what all the types are. I'm going to give you some practice problems here. You're going to name the type and the location. If there is any discontinuity, that's an option too. You can just say, oh, it's continuous.
It has to be.
Got it?
Like, can I get it right?
Not 100% sure. Again, eliminate it here, then we'll see what you think. You
You're
can talk
pretty
to
much
each other.
like one of two. Most likely.
Because usually the jump only happens in
And if
piecewise.
it's piecewise, don't you automatically get 1 point if you just know a jump?
No.
Oh, shoot.
What if they match?
then it's nothing.
Okay. And I could be mean and put like one of your pieces could have a discontinuity.
Oh, no, it's not.
Is it just an infinite?
Okay. Raise your hand if you think this is jump. Raise your hand if you think it's infinite. Raise your hand if you think it's a whole.
Wait, there's no discontinuity?
No, there is, but it's infinite.
Oh, what? Is it, where's it at though?
A hole is when it becomes a solid.
Okay, I got that part right.
Okay. Ben,
Why is it
I would take asymptote as well. Be aware, what if there's multiple choice questions and it uses infinite? You know, you just have to know what the terms mean, but I would accept either one if you're answering it.
So in order for it to be a whole, would the numerator have to be something that you can factor out?
If it had been,
Can I just follow the rubber sense and I love making that?
Is that the only way for me a whole?
the only way it's a whole is if you cancel out a factor.
Okay.
Yep. So, this is just an asymptote because we know x cannot be 7.
So it's infinite?
Infinite or asymptote, yep.
Will the whole have a factor on top?
Like you'd have to cancel out the x minus 7 to be
Oh, see, Joe.
Ooh, all right.
Got it. How do you know the answer?
Maybe. Maybe
Oh,
not.
the answer is.
Don't yell.
Oh, that's so simple. But
Jot
so
down.
if it's you know, do not write like you should, you know.
Yeah, you know. Yep.
I don't want to go
It's interesting. I think it's funny that the entire upstairs is blue.
What is that gonna do?
I don't know. And like, so can you not go to the office? Are they going to be like, oh, you should be upstairs?
I feel like I'm in like kindergarten or something.
I literally just went down to the council.
Yeah, but it does start out now.
I don't know. With what they put in my mailbox.
Oh, yeah, you go down to your locker.
You have a blue vest, you're not allowed. All right, guys. How many of you just automatically were like, ooh, piecewise, it's a jump?
Yeah, but then
I got that part yet? Okay. Okay, I'll give you a minute.
Still repeating.
Oh my, I heard so much
In this? Oh, I was like, oh, okay. I'm like, no factoring in this. So, guys, we need to plug 0 in, right? What do I get when I plug 0 into the first one?
Negative.
And then the second one? So what does that mean?
They're the same as
Right, so this is just a continuous function.
What about a non-discontinuous?
A non-discontinuous function, that would work too. No discontinuity, that would be an acceptable answer. Okay.
said no jump.
Oh, continuous works.
Well, just because there's not a jump doesn't mean that it's right, because there's others. I suppose if you were like, no jump, no asymptote, no hole, you should write continuous or not discontinuous. Do you really want to do that? Then NA would not be a good answer for this, okay?
None of those. I already know that's a. I'm not gonna say it out loud.
In discontinuous here. Alright.
I've got a feeling.
Yes.
this way, when it's a jump, that means that the piecewise function to
Yep.
It doesn't matter whether it's equal to or not.
Nope. Nope.
I feel like I got it right.
Guys, there can be more than one type of discontinuity in a problem. So, just saying, this one has 2. Fletcher, did you get 2?
Oh, yeah. I was going, yeah.
Okay.
I was confused for a sec, but now I know there's 2. I was like, wait, why? And I was like, oh wait, I want to punch it right. I'm nervous.
You're nervous. Okay. Yeah, this is a pretty stressful moment, guys.
I got that.
I hope not.
That's mine.
I hope I don't create a constantly stressful atmosphere for you. I know there are some classes where that's a thing, but I hope it's not in here. All right, did we factor okay?
Yes.
All right,
Wow.
that goes away.
Okay. Oh wait, that's wrong.
So, I crossed that one out. That's where the hole is. At x equals -1.
And then you have an asymptote.
Yes, and then you also have infinite or an asymptote at x equals 1. Okay, the one you cross out, what makes it 0? That is your hole. If there's anything still left in the denominator, that can be your asymptote. Okay. Ben.
Did you ever ask us to graph it?
Well, we already did in our rational equations unit. So I already have asked you. I'm not going to ask you to graph it in this
I honestly
unit.
don't remember each unit precisely.
Okay. Blur.
It's been too loud.
See how that final goes. You might want to look over them before the final.
Do the finals equations
No.
it's like they just take all the stuff and like combine it together.
Oh.
As in cumulative? Is that what you mean? I wouldn't say that that's exactly how it works in here because everything doesn't line up that way. All right, tricky one for you. Right, smaller? You know there's a whole nother page, right? Have you already used 2 pages? I think there's some scratch paper on the back shelf if you need some.
Las putas.
Yeah.
You say this country it's
Okay, me asking you domain is a totally different question.
but is it still counted as discontinuity?
If it's not in the domain? Okay, this one is in the domain. If it wasn't, then no, you would not include it. If the discontinuity was like less than 2.
Oh, it's just within the line. Within the line. Okay, never mind. I get it.
Okay.
When you're doing this one,
Mm-hmm.
and if or not one of them has an asymptote, you're going to include that.
Like include it as a part of the discontinuity.
Yeah, because like
Yes.
this right.
So you could have like a jump in an asymptote in this one.
Okay.
Give you a minute, guys. There's not a hole in this one. No holes. Not a hole.
And obviously continue on.
Are you thinking like where there's an asymptote,
Ah.
right? Yeah.
The jump at -2 also includes
Yep. You ready for me? Or are you still processing? Okay, I will let you process.
Yes. I'm really tired today. I don't remember looking at any of my lessons today. I was definitely there. When I was walking to the counselor, like I didn't realize I was walking to the counselor. I was so tired.
That one where you like got there and you're like, how did I get here? Not a good feeling.
You started. I'm sorry.
All right, are we ready? Have we processed?
I don't know.
Maybe. Okay, guys. Before I even get to the fact that it's piecewise, do you see in that first equation that there might be a discontinuity?
Yeah, infinite.
Yeah, so I know right away that I have infinite. I don't know what's going on in the back there. At x equals 3. Are we okay with that one?
Yes.
Okay. Then I have to plug in my x values to see if I have jumps. At 2, do I have a jump? Yes. What about at -2?
Yes.
Yes. So you can say, as we're falling apart today.
All right, let's go ahead and cut it off. Nice work, class.
We're close. If I plug -2 in, so that would be plugged into the middle piece and the bottom piece.
Yeah, you don't.
You see it?
No, but I thought it was only if it's like equals the same. So like, so I did too.
No, it equals the same. It's
Not,
continuous.
I didn't mean equal, but like it's both the same sign, so like greater than, x is greater than 2, and then I also found that.
So x is greater than or equal to 2, x is less than 2. So these two, and then x is less than or equal to -2, x is greater than -2, so the -2s I do in these two. Okay? And you get different things. Yes.
Okay, so I have a question. So, for example, if like plugging the first 2 into the x plus 2 over x minus 3, and then plugging the second 2 into the 3x mashup, would that still be a whole because you need the -2 also, or would it not? Okay.
Nope. Because you're just looking at that x value. Do they match? Excuse me. Sorry, guys.
So like the -2 on both of them was the same, and it wouldn't be a whole even if the 2 2s.
There are no holes in
I
this
mean,
problem
not
at all.
holes, jump.
Right.
Okay.
Yes. Just to make sure we're talking about the same thing. Okay. Right. Okay. Do you get the infinite part?
Yeah.
Okay. So the jump part. What if?
So like the first part of the first part of it just
What
isn't
if?
even.
I don't know how to. Okay. Let's pretend this isn't here. And then let's pretend. Oh, I don't know how many things I have going on here. Those are not there. And now, could you figure out is there a jump or not? Okay. Yeah? That's to figure out if there's a jump at 2. Do you understand like why I look at just those two equations? Yeah, the x is 2, like, yeah, so then to do that, yeah, I don't know why I have so many boxes. Oh no. Wah. Okay, and now you see, pretty much. I mean, you have to look at the x values, and if they're written in some weird order, then okay. Just make sure you match up like, oh, this one has a -2 and this one has a -2, so I use those two. Okay. All right, so we're okay with that. Okay. We have one more little thing. All right. End behavior. We've done this year. You did it last year. So jot it down. Let's see if you remember.
Oh boy.
You don't? We'll talk about it. And the notation, the way you write your answer looks like this. And guys, on your test, I help you out and I say, fill in the blank. Limit of f of x as x approaches infinity equals.
I like remember what this is. I just
Don't remember like how to do it? Okay.
Yeah.
Write it down and then I'll
the
show you.
pattern.
Okay.
Oh wait, I may remember this, but I remember I wasn't there.
This is vaguely familiar, is what you're telling me.
I definitely wasn't there.
No, this is easy. This is really easy. I promise.
When it's
If it was hard, I'd tell you because you need to know today.
When it's
Hard.
odd positive, I know. When it's okay, hold on, wait, that was wrong. Okay, when it's an even exponent but negative, it's negative. When it's an even exponent but positive, it's positive.
Just kidding. I was good.
I remember this now. I remember it.
Touchdowns, disco, yeah. All right. When you are talking about end behavior, guys, the only thing we care about is the biggest exponent, the degree of this, if you will. So biggest exponent, I'm looking at that guy, right? Okay, remember, if it is odd and positive, that's the graph we think about.
Yeah.
Odd and negative,
It's vice versa.
yeah. Okay. What do you think? Is this one odd and positive or odd and negative? Odd and positive. I'll give you a second and we'll fill in our answers, okay? Remember? So the notation, we are using limit notation. Limit of f of x as x approaches infinity. That means as you go really far to the right, where's your graph going? Infinity, because it's going up. Bless you. You see it? We're using this one. And as x approaches negative infinity. So as we travel left, where does the graph go? Down. So it is negative infinity. Okay. Let's try one more. Try B.
Oh, why did you do that? I'm sorry. How did you get that?
And then if it's even and positive, it's like this, and odd and positive, or even and negative, it's like this. Okay.
So I'll drop for you. Even and positive, we just think parabola. Even negative, we think upside down parabola. Okay. All right, guys. So this one's not written in order. Where's the biggest exponent? Like, what do I care about? Yeah. So it's actually this guy. So that's even and negative, right? So where are both ends going? Down. Down. Okay. Guys, let's see in the notes. You made it.
Is this?